portion to the course before it was actually, so I just started that last year. And really, I have a background, I used to work up at General Motors doing robotic simulation and some concept design. So I've worked with Unigraphics and SolidWorks, and now I'm doing Solid Edge. So I have a pretty versed background in a number of software packages.
Okay. You're using Solid Edge in your class?
We're using Solid Edge in the class, yes, indeed. I'm trying to get them to move to SolidWorks, but I'll get your opinion on what you think is most viable and translates best to what you guys, what the rest of Southern Ohio sees.
Okay. Very good. And Ted?
Ted, your turn.
Yeah, I teach engineering at Wayne High School in Huber Heights, and we have a project lead-away curriculum that we teach. We actually teach 5 different courses, and the first course, Intro to Engineering Design, is where we do most of our computer sim work and modeling. We use Autodesk Inventor as our software package, and then sometimes we go from that into a 3D printer, but that's about it. It's mostly first year so that they have it as a tool for their follow-on courses after that.
Okay. And do both of you have pretty good enrollment in your programs?
I
got 150 students.
Okay.
Oh, wow.
And they're all taking the CAD class?
They all end up having to take the CAD class, yes.
Okay. Great.
I'm only meeting, I have 2 classes, 15 seniors and 20 juniors. We're meeting 2.5 hours a day, 5 days a week. So it's a little different structure, but.
Yeah, we run a standard 50-minute period.
Mm-hmm.
And, 5 days a week, and they take it all year long.
Gotcha. So I'll explain a little bit about what we do here at Columbus State, which is pretty close to what most of the colleges around the state of Ohio are doing. It may not be exact. Everybody has some wiggle room and some curriculum that's kind of a little bit more tailored to their area. And so we'll kind of get started a little bit about the C tag, and that's what you guys are, what your CAD classes are for, right, is to get the C tag credit for the first CAD class, correct?
Yes, ideally.
Yes.
Okay. So I did a GAP workshop in Marion for that, I guess, division of tech prep, and had pretty good attendance to that. I don't know if there was 15, 20 faculty there from high schools kind of around the area, and it's going to be kind of a unique discussion today. So the C-tag is not what you guys are really doing, and it's not going to be that I disagree with what you're doing. I think you're doing the right thing. It's just this, you guys call it a C-tag. At the college level, we call it a tag for college-to-college transfer. And when this tag was developed, it was just a different world then. So we'll kind of talk about that and talk a little bit about the programs that are out there. And then I'm going to break this up a little bit. I'm going to let you guys kind of guide me here a little bit, but I'm going to show you some of the labs that we do, at least the first half of them. And I don't know that it's going to be advantageous for me to go through the software and show you how we ask the students to do these or not, but that's certainly an option here after we kind of go through what we do and how we do it a little bit, but we can do some software stuff too. So does that sound good?
Sure.
Okay. All right. So I started off here just looking at why we do CAD in general in the state of Ohio or either around the nation, but I just have some bullets up there. You know, the technical communication, it's, for me, it's a graphical application of problem solving. For a lot of people, it's a way of thinking that's different than what they've experienced in their math classes and in art classes and So the technical aspect of this and just being able to communicate graphically to this kind of detail is somewhat unique in this area. And then, you know, some big ones just for CAD in general, resolving design issues before something's made, create and design, collaborate, and self-expression with the cloud-based applications and the way some of the software is doing that. We can just do some wonderful collaboration now, especially in HTML5, so it's kind of universal. That works pretty well. But the last one there, I wanted to reinforce, it's just one tool needed out of many. I get so many students who just want to learn CAD, and they think that's their ticket, when it's just one tool in the toolbox. CAD by itself really doesn't do anybody any good. We need a lot of other things to go with it. So what I'm most familiar with is AutoCAD, Inventor and SolidWorks, and then Autodesk Fusion. And I know there's a bunch of others out there. For the parametric world, they're really all about the same. Inventor is just as good as SolidWorks, and SolidWorks is just as good as Inventor. And I really haven't seen any big advantages Solid Edge has. It's just that they're parametric, which is different than the non-parametric software. It's a different way of thinking. It's a different way of designing. And none of them really make a difference for me, except for maybe when you get into CATIA. And that's going to be the big division. CATIA and then Pro Engineer are kind of your higher level softwares that are really more for the engineer. So,
sure.
When it comes to engineering technology, you know, all of those work just fine. And then, have either one of you two worked with any of the cloud-based applications? For Autodesk, it's Fusion, and SolidWorks has one. I forget the name of it.
I have not, no.
I worked a little bit with Fusion, but usually because of time constraints, we usually jump right back into Inventor real quickly and go from there.
Right. Fusion is kind of a different animal a little bit. Once you get used to it, it's really a great application, but I think it has a little maturing to do yet. But
no, I agree with that, and it's not really in our curriculum. So usually what will happen is I'll get a student who'll go into it by accident and wonder what's going on, and we'll take that as a learning experience, but then we come right back into Inventor and finish our work there. Okay.
So some of the nice aspects about the new Inventor Fusion, which is partially web-based and partially PC-based, is first of all, it runs on any platform. It doesn't matter if it's Linux, if it's Windows, if it's Mac. It all runs equally well. It doesn't take a lot of horsepower to actually use, because anything that requires a large processing power or a large amount of RAM happens in the cloud. And we get, as educators, we get unlimited cloud credits. So if, as a professional, companies have to buy cloud credits to have things processed. So renderings, you have to buy cloud credits for, but in education they give us unlimited cloud credits. The only stipulation they put on it is that if their servers are backlogged, education requests go to the back of the log, but I've never had it take more than 12 hours for something to be put on the server. So when we look at rendering huge assemblies of maybe machinery or vehicles or things of that nature, that's just too much for a standard PC to actually churn through. So those type of things happen on the cloud. You can do turntable renderings, so it'll give you multiple views of your object. I do a lot of animation with it for classroom material. So in our CNC program, I can animate tool paths. For robotics, you can kind of animate different mechanisms and different automated things. It uses storyboards. It just works really well for that, but we'll see how it matures. So going back to the parametric for a minute, I think Inventor's probably the best because it's free. And,
good selling point. Yeah, Solid Edge. That's why we have it as well.
And
Solid Edge is another free one.
Is it? And
yes,
then can
indeed.
Students get versions of that?
Yes. Yeah, they can download it onto personal laptops. They just need a valid school email.
Right. Kind of the same thing for Inventor. And the other thing, if you do go with Autodesk, they really support education well in a number of fronts. But if you haven't looked at their educational community, your students get access to all the Autodesk software, the movie making, the animation, the clay-based design software. So if you have some students who are really, into software, there's just hundreds and hundreds of packages that Autodesk offers in all different kind of industries. So it's kind of fun for them to, you get some that really want to go into a different area. They at least have access to it. So.
I will tell you every once in a while I have a parent call me up and wonder why their computer system's so bogged down with all this Inventor software that I told their students to download, because they get on there and they say, oh, I want to learn how to program games and I want to do this, and next thing you know, they download all that stuff, and it does eat up a lot of space.
Right. Yep, absolutely. Well, let's take a look at the tag. So this is the college-to-college requirements, which is really the same as the C tag. So they're one and the same, but I kind of took them from this perspective because there's just a couple of things that are different. So the first thing I have up there down below, kind of bolded, the prerequisite for our CAD classes is an engineering drawing or an engineering graphics class. And if someone was to choose to cover that material within the context of a CAD class, we can waive that prerequisite. But here at Columbus State, we do not. So we have a separate engineering graphics class, and that's where they learn orthographics. That's where they learn dimensioning and detailed and the idea of section views and all of that stuff. So when they enter into my CAD class, I assume they already know all of that. And then I'm going to challenge them in their orthographics and isometrics and section views, but I'm not necessarily going to teach that. So that's kind of how we approach it. So I'm assuming you guys start your classes in the orthographic area where nobody's seen a 3-view orthographic drawing before, and that's where you start. Is that correct?
I would say, go ahead, Ted.
We start with some 3D modeling and building of objects, and then we get into the multi-view drawings, and then after they get the basic multi-view drawings with the 3 orthographic and the 1 isometric, then we start getting them into sectional views and more detailed views and things like that.
That's really the first opportunity they've had to see an orthographic document? Mm-hmm. Okay.
Yes. Mm-hmm.
Yeah, and I'm about the same, so, yeah, we do about the same.
Okay, Mark. So the requirements for the learning objectives is, we'll kind of go through these, but I got to tell you, these were written for a 2D CAD application. So this is really an AutoCAD class. And this comes back when the tag was originally created. I think it was around the year 2000. So it's been, I'm guessing here, 15 years, right around there. And everybody had an AutoCAD class back in 1999, 2000, and it was kind of the main CAD class for all the programs around the state. And then once that gets written into a tag, it kind of becomes law, and it becomes almost impossible to change. The state of Ohio has never went back to kind of review these to see if the situation is still the same as it was. And I think that kind of comes from there's a lot of stagnant degrees out there. There's just, you know, math hasn't changed that much. English hasn't changed that much. But we happen to be in one of the technologies that change drastically. A little bit from year to year, but you give it 5 years and it's just a very different field out there than it used to be. So I've been petitioning that this really has to be updated to current industry uses and demands, and they're looking into it, but as it stands right now, this is a more of an AutoCAD-based class. So that's
when you say this, you say the one the tag is, or the one that you end up teaching. Yeah, because obviously this is dated. I mean, you got to start 3D anymore. I mean, that's.
Well, it depends.
Well, okay.
I'm kind of with you, but there's still, and I'm not, I guess. Okay. We still have an AutoCAD class, and it's one of the CAD classes in our curriculum that all the mechanical engineering technology students take, and it's still very useful. So all the engineers that I know in the Central Ohio area have a version of AutoCAD on their desk. So is primary design software, yep. Is their primary design software parametric? Yep, absolutely. But do they use AutoCAD? Yep, they sure do. And there's problems that are easy to solve in AutoCAD that are not easy to solve in 3D. Not all of them, but there's some. And this, for me and for us, really reinforces the orthographic drawings, which is really going to be their primary job once they leave here, that they're going to have to look over drawings, they're going to have to interpret drawings, they're going to have to build things from drawings, they're going to have to do quality control, inventory. So one of their main tasks is understanding orthographic projection and being able to interpret those documents. So the CAD class really reinforces that well.
Okay.
So that's why we have it. Now, we have a separate class that's parametric. And I'm going to go over that, not today, but maybe Thursday or next week. We'll kind of see how this goes. I'm going to let you guys help me drive this a little bit. But for today, we'll kind of look at what we do in AutoCAD so you have a flavor of that. All right? Are there any questions over the learning objectives up there?
No, sir.
Okay. Now, one thing that's not in your C tag that's in our tag is the last 5, I believe, at the bottom, last 4 at the bottom. For those are optional. They're recommended, but they're not a requirement. And I just have them up there, gain an appreciation of the ANSI standard for symbols and terminology, understand standard engineering symbols, prepare electrical connection wiring diagrams, and introduce GD and T. So we try and do those things. We don't do them real in-depth in this class. Happens in other parts of our curriculum, but for us it is part of it, but it's not required. Back to why we even have this class yet. One of the reasons is the state of Ohio requires it, and the other reason is that it's still useful, and just all the things we kind of talked about earlier, the interpreting engineering drawings, communicating ideas, which doesn't always happen in 3D, especially around the conference table or on the back of a napkin kind of stuff. We see a lot of our graduates, their first job is going to be detailing and altering completed drawings. So, nobody's sitting off designing the next fuel pump for rocket, but are given some tasks, alter some drawings, and make some changes. A lot of them are producing items from orthographic drawings. I have a lot of people working in the prototype industry, and they're just simply given a print and asked to, assemble it or create it. inspection of parts. We have companies that, you know, as their employees roll over and there's turnover, they end up with people in their inspection department that can't read a drawing and they can't inspect the parts anymore. So they send them here and they go through engineering graphics, and we'll also send them through the AutoCAD class because it's just part of that orthographic projection area. Inventory control at Honda is huge, especially for their R&D. They have to compare the parts coming in against drawings, assembling components, and then just kind of designing. So that's where we see our graduates being employed with those kind of assignments or tasks.
Mm-hmm.
So I mentioned earlier that we divide our curriculum up. Our engineering graphics course is, we start them out sketching, so just grid paper and pencil and a straight edge, and they're starting off slowly in front, side, and top views, and we do move them over to technical drawing on paper for a period of time. I know that kind of seems archaic, but in the world of engineering, that's kind of what an engineer should enjoy, is that kind of neatness, detail, concentration. So we give them a little bit of that, and then we do an introduction to CAD in the engineering graphics class. So they've done some drawings, they've started the software, they've manipulated it, and I kind of always say they know which direction is north on the compass when they leave. Then they enter into our MEC 1145, which, as I mentioned, is a non-parametric CAD course. We do 2D drawings, and we do those from dimensioned isometrics. That's 40% of the class. So I don't give them the answer. I give them a dimensioned isometric, and then they have to create the orthographic drawings. After we're done with that, about 10% of the class is actually creating isometric drawings from orthographic views. So I'll give them dimensioned orthographics, and they have to create a couple of isometric drawings. It's just a quick way to get a perspective. I can create an isometric faster than I can create a 3D model for some parts, and just, you know, for a rapid form of communication, that works pretty well. And then we do 3D solid modeling, which is about 50% of the class. And about half of that is they actually create models from orthographic drawings. I give them the orthographics, and then they create the models. Then another half is just simply designing in three-dimensional, where I don't know the problem, I don't know the solution to the problem, but we all kind of tackle it together and go down that road. So that's how I've organized our class that covers this tag. The 2D orthographic drawings portion of the class, it starts out slow with simple parts, gives them a chance to explore many different aspects of the CAD program, chance to see different techniques for solving problems, ramps up pretty quickly, and the students are required to use different techniques to produce the drawings just because of time limitations. That it's not get it done any way you can. It's you have to use different techniques to be able to accomplish the tasks in the time that's given. So that's kind of the 2D section of the class. So this is how we evaluate them. So for the class overall, over there on the left, the individual lab assignments are 50% of their grade. There's some hands-on quizzes that are 15%. Project exams, I try not to do a final exam. I usually do a project with them that's kind of done in teams and multiple people working all on the same goal. That's 25%. And then attendance and class participation is 10%. And then we kind of have a little bit different of a grading scale there. We'll hold them to a little bit higher standard in the engineering classes than typically done in the gen eds and some of the other classes. So that's the grading scale. For the 2D portion of the class, I have my lab points up there. I make all labs worth 100 points, and then I take 5 points off for every mistake, except for the last 2 down there at the bottom. It's only worth 2 points. But I can take a lot of points off on a drawing, especially when it comes to the dimensions, double dimensions, unclear dimensions, incorrect dimensions, geometry. Really hold them to a pretty high standard there. And I have no problem giving somebody 20 out of 100 on a drawing that they turn in if they've actually made all those individual mistakes. But I do give them a chance to correct them. So I think for the first 5 labs, they're able to make corrections and turn them in again to get their points back. But it's the way I communicate to them what they should be doing and what they shouldn't be doing, because dimensioning is just such an important aspect of this. We can't afford to make mistakes in that. So that's the technicalities of the class. I'm going to go into the labs we use for the 2D portion, but I do understand that if you guys aren't going to do AutoCAD, this is kind of pointless. And this is something we have to fix at the state level. Would you agree?
Well, certainly. I guess I'm trying to. I mean, my background with General Motors, I can't actually. They did layouts in 2D up there, but for the most part, everything we did was 3D. So I'm teaching to that kind of. I'm teaching with that background in mind. Now, certainly the standards indicate, we have to stick to. We still have to teach orthographic views and some general 2D, but I guess at least for my background, I felt like 3D was kind of the direction to take the class.
I would agree with that.
But you're certainly right. I mean, it's at a state level. I'm not sure who we talk to kind of get that changed. If that's I'm not from Southern Ohio, so I don't really know this area. What's necessary, what's needed down here is a big part of it too.
Right, and I think when I did the GAP workshop, Rob Speckert. Are you familiar with Rob Speckert?
Absolutely.
Okay.
Yes.
So he acknowledged that there has to be some updating here, and he's brought it up at the Board of Regents, but the state government just does not move fast, and then education doesn't typically move fast either. So we are working on it. We're constantly telling them that this has to be altered or changed or given some leeway in this, but as of right now, it just hasn't happened yet. So I hold out that we'll make some progress. So
yeah,
go ahead.
I'd like to see what you do, simply because you probably have some good stuff that I can go ahead and adapt over to my stuff, because we don't get a whole lot of lab setup and stuff like that with the curriculum that we're in. So I'd like to see what you do.
Sure.
Well, and same with me, Shane. I mean, my background's a lot of 3D, but getting into the finer points of 2D and even understanding what's important to for this class and what you're doing. So I'm all for, if you wanna keep going the way you're going, I'm happy to pick up everything I can. So.
Okay. And then if you guys are willing to come back Thursday, I'll try and have some material that I do in the parametric class, so that you can see the labs, because it's just different. Like if you tried to use my 2D labs in a parametric software, well, they probably wouldn't be all that challenging. It requires a different approach. Now, I will say from the GAP workshop, one of the things that came up is what happens when your students come to my program, or really any of our programs at the college level, with this CTAG credit. Because that has implications. So if I have one of your students come to Columbus State and they come and talk to me and they have the CTAG credit, but I find out you've really they were really in a parametric curriculum. And that means they're going to take my parametric class where we're going to start parametrics from the beginning again. And that just really doesn't make sense. So by the law in the state of Ohio, they do not have to take my AutoCAD class. And if they want to leave it at that, that's fine. They can sit through my parametric class, and it'll be, partially a review. Maybe I do some things you didn't, or I go into some areas you didn't, and vice versa. But I'm going to encourage those students to move that credit over to the parametric class so that they get credit for my parametric CAD class and that they take this class. Because another software package, another view of it isn't a bad thing for them. So that's kind of how I deal with it. And I feel that's how a lot of my colleagues deal with it around the state, because we just don't want somebody in class who already knows the material. It's no fun for them, and it's no fun for us.
Well, and I guess... No, go ahead. Sorry.
No, go ahead, Mark.
Well, the other thing is, honestly, the way I look at it is part of the reason that we have this presentation. I can go through and I say, okay, to get through my class, you need this. To actually get the CTAG credit, you're going to have to go through these other, there's additional depth that you need to get that CTAG. And so that's the way I'm intending to handle and have handled it in the past, where the whole reason I'm attending the CTAG workshop is I want to know that when my student, if I give them CTAG credit, they're going to be successful in whatever they do. That assumes that they have known, that they understand, that they've gotten their full, the knowledge that they need to be successful. It's not just about college credit, it's about knowledge. So,
but, yep, and going back to the dilemma here, again, you guys are doing the right thing with doing 3D and parametrics, because it's definitely where the majority of the CAD is, but it's also fun, and students like that. And it's going to get them it's going to get them started in the programs and hopefully keep them in the programs, and that's what we desperately need, is more people choosing this career of engineering, manufacturing, technology, whatever it is. So, all right, let me show you what I do in the world of 2D here. So in AutoCAD, I give them some standard layers. I'm not the first couple of labs. I have them create their layers every drawing because they kind of need that. If we only did it once and created a template and worked from that, they would never remember how to create a layer. So have them create them for every drawing for like the first 4, and then I show them how to do a template so that we can just create them once and use them every drawing after that. But I just have them assign standard colors so that I can, when I look at their screen, I visually know exactly what lines I'm looking at. And then I have line weights up there and things of that nature. So this is one of the standards that I hold them to, I guess. And then this is where I start off. This is their first lab, and you can see it's a dimensioned isometric. And when I converted these to PDF, some of the lines didn't come out perfectly, but I usually print them right off of AutoCAD, and they get a little bit better print than this. But as you can see, they create front, top, and side view for this part. It has an oblique surface on it. It has kind of that channel cutting through it, so they have some hidden lines. They have some features to project from the front view to the top view to the side view. Kind of up to them to figure out, like, where do you create these features. So, for instance, the holes. The holes are the easiest to create on the top view, and then project them down as hidden lines to the front view and the side view. So I'm trying to give them some techniques here. It's not just about creating each view independently. It's about being able to transfer things and use the geometry that you have on the screen wisely, and trying to make this as easy as we possibly can. You'll also notice that on all of these labs that I have for the 2D, I have not dimensioned them perfectly. So first of all, they're isometric, so I'm kind of limited in how I can put the dimensions on there. And then secondly, I don't want to give them the perfect dimension placement. I want them to come up with it. So I tell them, if you just duplicate the dimensions I have on this isometric on your orthographics, I'm going to take a bunch of points off because for sure it is not the most appropriate way to dimension a lot of this. So this is the first lab. Any questions about this lab or comments?
No, that looks good.
I have a question in general, not about the lab, but where do your students pick up their dimensioning skills?
In the engineering graphics class, they are introduced to dimensioning, so they at least know the rules. You don't dimension to a hidden line. You don't double dimension things. You try and keep the dimensions on the inside of the views as much as possible, all the standard stuff. But they typically don't remember that very well. You know, they kind of had it, and then sometimes they forget it, or they didn't take it seriously. They didn't understand how important that was. So I'm reinforcing it in this class because I deduct so many points for every dimension off. So when they get that first, second, third, maybe even fourth lab back and they're getting 20 out of 100, that really makes them pay attention.
Okay, because we're dealing with primarily freshmen in high school, and we're trying to teach the dimensioning along with the modeling, and I find that they're extremely confused and weak in this. And Autodesk is great for putting certain things in, but they're just, it's not just automatic to the students, and things like hole dimensioning and stuff like that usually drives them up a wall.
Right. And we do a lot of that in the sketching part of the engineering graphics course.
Okay.
Where they're sketching orthographics, and then in the technical drawing part, where they're actually trying to produce a couple of technical drawings with, you know, pencil and or mechanical technical pencil and triangles and a T-square. Again, we're using that to really teach them the dimensioning and the finer points of that. So then I hammer them again in this class.
Okay,
but,
thanks.
But I think you're right. It's just too much to teach CAD and the engineering graphics part of it, because it's all new, and if you've been doing CAD a long time, it's second nature. It seems easy. But when it's the first time you see, whether it's parametric or non-parametric, man, it's a fog.
Right.
So, yeah,
no, agreed.
I'm all for kind of breaking that up a little bit. And you could do that in your class. You know, there's no reason a CAD class has to start off in CAD.
No. Hey, Shane, unfortunately, I have a credentialing class tonight as well, so I'm double booked, and I have to get going. I can't be late to that one, but I appreciate everything you're doing here so far. You know, certainly this a lot of good information here, and I'll pick back up on Thursday. I should be able to stay full time on Thursday. On Thursdays. Tuesdays are just my I was hoping to not be double booked this quarter, but it looks like it's not going to happen. So.
No, I understand what that is.
Yep. Have a good night, guys, and thanks again, Shane.
All right. Thanks. All right. So, Ted, it's just you and me, correct?
Yes.
All right, so I'm just going to go through. I've got 8 labs here. We'll go through them kind of quick, and we'll call it a session. How's that sound?
That sounds good. And I'll try to share with you some of the stuff that we do.
Okay. So this is the lab 2, and this one poses some challenge when it comes to the hidden lines. Just the way that front kind of looks like a T there at the front, and kind of the way I've dimensioned it, it does challenge them in trying to figure out where all the lines should be, and I call it the classic tombstone up there on the back side of the part. everybody wants to dimension the overall height to the top of the tombstone and give me the radius and double dimension things like crazy. So this is the lab 2. Lab 3, I brought this one in to just really reinforce the tangent snap command in AutoCAD, and it would be the same in parametric, the tangent constraint, but getting all that circular geometry up there and getting the lines tangent and getting that to look right, just kind of reinforcing snaps here and making sure they're using those and understanding the importance of them. This one just has some hidden line challenges, the way that hole goes through those rounded tops and where the lines become tangent to the circular geometry and the oblique surface, and kind of have that channel running through the front of it gives them some challenges on some of the orthographic views, really makes them think about how to transfer their lines from one view to another, where if they're just drawing the views independently and deciding where these lines should be individually, they usually get it wrong, where if they would transfer things from view to view, they would have a much better drawing, and they start to understand that here in this lab. This is one of my favorite labs because they always get the hidden lines wrong for this. So if you look at the front of that cylindrical body, there's a groove that runs through the front of it that's kind of machined out. And that creates some really weird setbacks, what that groove looks like in what I would call the top view. And universally they get this wrong because they're not transferring the changes in direction of surfaces correctly. So after this one, they start to understand the importance of really transferring lines and hidden lines, and we don't get to make up what the views look like, that they have to be correct. This one's starting to get a little more challenging for them. There's a little bit more going on here. This requires a section view to mention that oblique surface that's kind of in the center of that. And then this is a good example of my poor dimensioning that's on purpose. So for instance, I have the center of this hole dimensioned from where this radius stops at right here. And almost every time they'll give me this same 2.5-inch dimension, which is just absolutely wrong. So nobody would ever dimension the placement of that hole where this radius blends into this flat surface. And so just different little aspects of how I've dimensioned these parts and what I've chosen to give them and not give them kind of poses those challenges to them. And that they hopefully start to understand some of that. So. This is my lab 7, the second to last one. So this one has some unique challenges to it. Have this web running through here, top and bottom. You can kind of see that in this isometric section view. But just where these lines connect to the cylindrical bodies poses them some challenges. Kind of have this flat surface running into this cylinder, and it's not on center, so that just creates a lot of hidden lines in that top view that they really have to think through. And there's also a groove that runs through the bottom. I've kind of shown that in this isometric view. So this one gets pretty complicated for them when it comes to hidden lines and attachment points and projections. And then this is the last orthographic drawing that we do. It's kind of a larger drawing, so we have to deal with scaling. And in AutoCAD, that's a big deal when we go into our paper space and scale our views and try and get our dimensions scaled appropriately, and leads us into some different aspects of CAD. And then again, oblique surfaces running through there. There's just a lot going on when it comes to the AutoCAD portion, but that's where we end the orthographic part of this. So.
Okay. Now, what is the deliverables that your students are expected to hand you as part of this lab?
The 3-view orthographics, along with any section views or auxiliary views that would be required in them. They turn those in, and then I grade them according to that lab sheet that I showed you, the 5 points off for everything. So,
now, are you having them hand sketch those, or are they doing those on their CAD program?
They're doing them in AutoCAD. So all of this is done in 2D AutoCAD, which is 40% of the AutoCAD class. So after Lab 8 here, we would go into, I think I have them do 4 isometric drawings, and then we only take about a week for that. And then after that, they'll do 3D models in AutoCAD.
Okay. See, are you familiar with the Project Lead the Way curriculum for their first Intro to Engineering Design course?
Yes.
Okay, so we do the hand sketching early on in the year just to teach them how to do isometric sketches and some orthographic sketches. But once they get into the computer, the thing about Autodesk Inventor is once you build your 3-dimensional model, it basically projects your orthographic views for you.
Right.
And that always puts the hidden lines where they belong, stuff like that. So we don't have quite the issue with the view itself. Now, we do have issues with the students dimensioning it because you have to tell Autodesk where you want to dimension it. And some of their dimensioning procedures are extremely rough. And they also lose track of the fact that Autodesk does not put in center marks and center lines for you, so they have to go ahead and put those in. But it's very different. And we culminate, probably the biggest project we get close to what you're doing there would be a miniature train. We do an arbor press also. And I think you have the option, you could either do a button maker. I think we have 3 options we go with. I usually go with the miniature train, where we present the student with isometric views very similar to what you have in your labs. And then they have to model them in the computer and then do the multi-view sketches from them after that. And then we start trying to get them into assembly and assembly constraints and all that other stuff to teach them other things that should go into their technical packages.
Right. Yeah, I don't know that they really, the technicalities of an orthographic drawing, whether you're creating it or interpreting it, it's just hard in the parametric world to get that across because it does so many things for you.
Well, usually what I've tried to do in some of my labs is actually give them the orthographics and then ask them to model the 3D model to see if they're properly interpreting the orthographic views.
Right.
Because like I said, if we build the 3D model, the program gives us the orthographic views pretty much, and it becomes a dimensioning exercise after that.
Right, and even the dimensioning, there's still a lot automated in dimensioning. For instance, when you do a leader like what's up on the screen, this dimensioning these radiuses, an inventor, it always points to the center.
Right.
Right, it's automatic. So they don't always comprehend that an arrow has to point to the center, so that if they had to hand sketch something, would they get that right or not? Well, probably, but yeah, just so many different ways you can go with that. I can tell you, like you expressed some frustration in the inventor dimensioning, like it doesn't do center lines automatically. Kind of does, but you have to ask it to, and then it doesn't always put all of them in. That if you show me an orthographic drawing, I can instantly tell you whether that was done in SolidWorks, Inventor, CATIA, because they all have some limitations and they do it a little bit differently. So you can definitely see that in the output.
Yeah, and my primary purpose is to try to get them to be able to interpret the drawings so they can get it into a 3D model, and then after that, in the follow-on years when they're continuing to use this as a tool, then to make sure that they're using the tool correctly so that they can tell a shop what they really need built as part of their design.
Right.
So that's the way we approach it, and the view that we take on it.
Yep. And, you know, for the most part, everybody around the state's trying to do a good job and probably is doing a good job. It's just, you know, you're limited in the maturity of your students, and you're limited in what they want to do and are willing to do. Like I said, I think if you started a high school student off with this class, they probably aren't going to be very inspired to go on.
Oh, actually, they love the first year. I get a lot of students that, sort of like what you expressed, once they get into the computer programming, it's like, okay, now I can do engineering and I don't have to learn anything else. Right. You're trying to talk them into, no. I'm trying to teach you a tool to use as an engineer, not to make you a person that sits in a shop and just does CAD drawings all day long.
Yeah, I wish those positions existed where somebody just gave you a drawing and said, duplicate this. But,
yeah, so, but they actually enjoy the first year. The following years, we really get into a little bit more of the mechanics of engineering and then design after that. And that's when their weaknesses will show up the most as far as using Autodesk Inventor, because they have to document their design. And that's where they get them. And, you know, like I said, Autodesk is kind of nice for your orthographic views, but then they also get to the point where they believe every drawing is nothing more than an isometric, a top, front, and right view. And they forget to show details and sectional views and auxiliary views and things like that.
Right, yeah, if they had to build the parts that they were creating drawings for, they get a different perspective.
Yeah, and that's what we're trying to emphasize to them, is that what we're trying to teach them is how to document their design so that they can take it and actually have it made and come out with what they believe they actually wanted.
Right.
And in their fourth year class, we actually have them start to deal with some shops. And the people we deal with have no problems coming back to the students and saying, well, I don't understand what you're asking me to do here, because this is not very good.
Right.
And it does open up their eyes. So.
Yep, absolutely. And you have to stay on the grading. Like I said, I just take so many points off. I do give them a chance to get those points back, but it's getting 20 out of 100 for a college student is a real wake-up call, as far as how much effort and attention to detail and understanding that they have to put into each assignment. So.
Okay.
So now, I will say before we end here that we were talking a little bit about how do we handle this with the state, and how do we kind of get the state to change a little bit so that this isn't technically the type of class that you'd have to offer at the high school, that you could do the parametric and the world would be perfect. With the College Credit Plus, where our classes are going to be offered in the high schools, what I've done is it used to be you had to take engineering graphics here at Columbus State, and then the next class was this non-parametric CAD, and once you completed that, then you could take parametric CAD. So I've taken the prereqs off so that you can take parametric CAD after engineering graphics, or you could take the AutoCAD after engineering graphics. And that's going to give us the ability to offer the parametric CAD in the high schools for credit. And it can be kind of the more fun, exciting, engaging CAD program that they see from Columbus State versus the highly technical AutoCAD part that probably isn't as fun as the parametric. So that's how I've tried to deal with it locally.
Yeah, I agree with you. There's from an instructor and project lead away, there's a big disconnect between the national organization and the state of Ohio and what the requirements are. So the school basically wants to try to get as much credit for the student as possible. And that's one of the main reasons why I jumped on looking at these courses, so I can make sure that we're aligned so that when they do get credit for something, they don't go to you and then all of a sudden be totally lost.
Right. And I'm going to move them. They're going to come in with credit for this class, and I'm going to suggest that they move it over to our parametric class so they don't have to take that, but they would have to take this class then. It's a mutual decision. I certainly wouldn't do that without their agreeing to it, but it just makes the most sense that most of the high schools are going to do parametric CAD. I think it's what you should be doing at the high school level. It just, when they come into the college level, they thinks that we are, so.
Yep, I agree there. One thing, one good part about it is we do a lot of documentation for the students, so they do show up with portfolios and stuff, and that hopefully will help the different universities and colleges mesh where that student really needs to be in their curriculum.
Absolutely. Well, I think we're going to leave it here today. Not going to take up your whole evening, and then, Thursday I'll kind of play it by ear here a little bit. I'll either show you what we do in 3D AutoCAD, or we'll try and move into what we do in parametrics, because that's probably going to be a little more useful for you. But I'll give you a little of both. How's that sound?